Okay, so this is a review of what we did Friday about solving equivalent systems using elimination. So they give us a system with three equations of three variables. Notice that we have an x, a y, and a z in all three columns. So for elimination, we have to eliminate. To begin with, we've got to eliminate one variable. And you have to look and study these and decide, what am I going to eliminate? And actually, I'm going to go with what the book did. So let's look at what they did. They took equations 1 and 2, and they're going to eliminate y. Okay? You're not limited to that. You can pick equations 1 and 3 and eliminate z if you want to. It doesn't matter what you do, as long as your math is correct. In the end, everybody will have the same answer. So 2 or 5 people can work them completely differently and all end up with the same answer. So I'm going with the book for demonstration purposes and for you to go back and reference. Okay. So the book says they're going to eliminate y using equations 1 and 2. So here they've copied equation 1 and equation 2. Notice that they keep the curly bracket to show this is a system. These are working together. So if we eliminate our y, what do we need to do? Well, if we're going to add these to eliminate, it means we have to have a positive and a negative. So if I have a positive y and a negative y, when I combine them, I go to 0. So we need to do that. We need to make one of the y's negative. So that means I'm going to multiply this by a negative 1. And that means if I multiply one of them to get my negative 1, I have to multiply all of it to get my negative 1. So that's what we do. Multiply this whole top line by negative 1. And you get a negative x minus y minus 2z is equal to negative 3. And that's because we distributed that negative 1 to every term on both sides of the equal sign. So after you convert equation 1 with the negative 1, now we're going to add to eliminate our variable. So when you add, you get an x, the y's go away, plus z is equal to 4. So now we're going to call that new equation with the one variable eliminated equation 4. Now we've used equations 1 and 2 from our original systems of 3 equations. Now we have to do something with the third and eliminate the same variable y. So that means we have to either use 1 again or 2 again, because we have to have 2 equations to eliminate with our third equation. The book chose number 2. So they chose to work with 2 and 3. And we've got to eliminate a y. So if you look at what they've done, we've got to eliminate y, and I'm going to circle this. So notice that I've got a negative 2y on the bottom and a positive y on the top. What could I do to make this go to 0? Well, right now it's not going to go to 0. I really need the top to be a positive 2y, right? Because if it's a positive 2y, then when I combine it with a negative 2y, it goes to 0. So that means I've got to multiply this whole top line, equation 2, by 2. So when we do that, you get 4x plus 2y plus 6z is equal to 14. So they converted equation 2 by multiplying everything in that equation by 2. Now I can add. So it's a straight copy across for equation 3 and then add. So we end up with 3x, the y goes away, plus 7z is equal to 24. So now we have our equation 5. So we've had equation 4 from the previous calculations, and here's equation 5. So now we've eliminated one variable. Now we're down to Algebra 1 stuff. Now we're just at a 2 equation system of equations. So what we have to do now is eliminate one more variable. Using equations 4 and 5, write those, and here they are. Equation 4, that one is here, and this one is here. And now we have to eliminate another variable, and it's your choice of what to eliminate. Someone says, how do you know what to eliminate? It doesn't matter. Just do what looks easiest for you. In the end, if your math is correct, you'll have the same answer. Now the book chose to alter equation 4 and to get rid of the x. So to do that, what do I need to add with 3x to get 0? A negative 3x. So that means I have to multiply the top line by 3, negative 3. So negative 3 times x is negative 3x, negative 3 times z is negative 3z, and negative 3 times 4 is negative 12. So now I've converted that equation 4 right there. And now straight copy equation 5 over. Now add, and I get 4z equal 12, or z equals 3. Now I have one of my answers. Because what am I looking for? A point out in space, x, y, z. Well, I've got the z coordinate for that, and that is 3. Now that I have one variable, I can plug my z back into either equation 4 or 5 and get my x. So let's do that. So we're going to pick the first equation for, we're going to pick this equation, plug in 3 for z, and what do we get? You get that x is equal to 1. So now we have two equations. We have z is 3 and x is 1. So we have 1, y, and 3. Now that we have our x and our y, now go back to your original equations, any one of the first 3, and plug in 1 and 3 for x and y, or x and z, and solve for y. That should have been a z, sorry. Alright, so you go back to any one of these and plug in x and z and solve for y. So let's see what the book chose to do. They chose to use the first equation. So it is x plus y plus 2z equal 3. So now we're going to plug in a 1 for x, right there, and a 3 for z, right there, and solve. And we get y equals negative 4. So now we have all 3 variables. We have 1, negative 4, and 3. And that is your answer. So how do you check your work? You take this point, 1, negative 4, and 3, into all 3 of your original equations. Plug in your x, your y, and your z for all 3 of these, and make sure that it makes a true statement. If it doesn't, you've either made a math calculation or you've got the wrong answer. I mean, a math miscalculation or a wrong answer. Okay? So that's how you do these, and this is just review from Friday. Does anybody have any questions? Okay, so what I would like for you to do, whoops, wrong one. Okay, now we're going to move on and we're going to talk about substitution. Okay, so problem 3 says solving a system using substitution. What is the x value in the solution of the system? And they give us 4 answers to choose from. A is 1, B is 4, C is 6, and D is 10. They just want our x value, right? But we notice here we have 3 variables again, an x, a y, and a z. Well, actually we don't. Let's look again. In the first equation I have an x, y, z. In the second equation I have an x and a y but no z. And in the third equation I have a z and an x but no y. So using elimination would prove to be a challenge. There's an easier way to do this, and what it is substitution. So now we're going to learn how to use substitution. and solve our system of equations with three variables. So the first thing you want to do is scan your equations. That's the first one is long and lengthy and has the three variables. The second one, I notice, there's that thing we love to see, a coefficient of 1 on the x. That's probably our contender. But go ahead and look at the third equation. We have a 4z minus a 5x equal 4. So it looks like the easiest thing to solve for is going to be our 2. And what we want to do is solve this for one variable. So if we take equation 2 and solve it for one variable, we would probably choose x, right? Because what would we have to do to solve for x? X plus 5y equal 9. To solve for x, this is just a literal equation, and we would subtract 5y from each side, right? And then we would get x equals 9 minus 5y. Okay, so that was easy enough. So I'm going to go ahead and mark this out to remind me to use this instead. Whoops. Oh no. Don't do this. Alright, sorry about that. So we're going to now use x equal 9 minus 5y instead of equation 2. What was there previously? We're now going to use x equals 9 minus 5y for equation 2. Now what we want to do, everywhere there is an x in the other equations, 1 and 3, everywhere we see an x, we're going to replace that with what? 9 minus 5y. Okay, so that's going to go in there, and it's going to go in there, and then we're going to solve. So here's the work. So in the first equation, over here on the left, they start with 2x plus 3y minus 2z equals negative 1. And they take the x and they insert for x 9 minus 5y, because that's what we got, correct? Now distribute the 2 to our two terms, and everything else is straight copy, and then just start solving for y. Oh, excuse me, we're not solving all the way down. We're just getting it to two variables, okay? So when you simplify this, you end up with negative 7y minus 2z equal negative 19. And we're going to call that equation 4. Just like we did before, we're narrowing it down. So we've knocked out one variable, and we've got an equation with two variables, y and z, and we're going to call that equation 4. Now we're going to repeat the process with equation 3. So start out by writing the equation, substitute the x value, 9 minus 5y, and solve. And we get that down to the same two variables, y and z. So we get 25y plus 4z equal 49. That becomes our equation 5. Now we've eliminated one variable by using substitution. Now we're going to continue to eliminate just like we previously have by elimination. So now take these equations 4 and 5 and think, how can I combine these to eliminate a variable? Do I have to multiply it by something? What do I want to eliminate? Well, it looks like the book chose to eliminate the z values because they're the smallest values out of y and z. And what would they have to do? Well, they have to make this negative 2z a negative 4z. So they're going to multiply everything in this equation by a 2. So you get a negative 14y minus 4z is equal to negative 38. So they converted the first equation, equation 4, to this. Now, straight copy of 5 straight over, and when they add these, then we eliminate our z, and we end up with 11y equal 11, or y equals 1. So now we've got one of our variables. Our x, y, z, we got our 1, which was our y, which is 1. now it's the same thing we've been doing. Now go back to either equation 4 or equation 5, plug in your y, or your value 1 for y, and solve for z. And you get that z is equal to 6. And now that we have y and z, now we can plug that back into equation 1, 2, or 3 and get our x. So let's look back at the equation. Oh, I erased it. But remember when I said x is equal to 9 minus 5y? Oh, we can get our x value very easily just by plugging in value y, which was 1. Right? So 5 times 1 is 5, and 9 minus 5 is 4. So now we know that our x value is equal to 4. And that's what they ask us for. What is the x value? So we would say choice B, number 4. And that's how you solve using substitution. So you start out with the substitution, but as soon as you eliminate one variable out of the first 3, then you work it the same as elimination. So there's not a lot different here, just the first step. Are there any questions? Okay. So here's the recipe card that I made. The substitution was from yesterday, the one on top. The elimination is the one for today. So you're welcome to take out your phones and shoot a picture of that now. Or I will also, well, it's in the video, so it's going to be online as well. So it's up to you. Anybody want to shoot a picture? Okay, I'll give you a minute. Hurry, please. Okay, thank you. All right, so that's going to be online a long time because I didn't pause. Okay, so tomorrow we're going to work. I didn't think there was a word problem, and then I just looked at the test, and there is. So we'll work this one tomorrow, and we'll work the one number 5 tomorrow. So what I want you to do now for the rest of the hour is work on 3 and 4. Now I have your paper because you turned them in, so I'm giving you these to write. So here is equation 3 and here is equation 4. Notice that on equation 3 they gave you a push start. So if they started it for you for number 3, you've got to finish it. So what did they give you here? Equation 4. See, there's 1, 2, 3. They took you to equation 4. Now you've got to go get equation 5 and continue to finish the assignment for 3. And then work 4 by yourself, and you'll turn these in tomorrow. Okay? Any questions? Okay, that's it for today. Yeah, and thank you very much. And I'm going to stop the video.